Welcome and thank you for joining. In this session, we'll explore factoring polynomials. Now recall that we have learned how to factor polynomials in grade 10. We looked into a variety of polynomials, and various polynomials will require different strategy. So we're going to try to go over different strategies today with examples. But remember that our very first step will always be to take out the greatest common factor if possible. So sometimes the greatest common factor can be in monomial or in binomial form. And then we check and see what type of trinomial we have so we can select the correct strategy to factor. So we're going to start with the first example. These are examples where we have a monomial common factor. So the way we look at it is, let's say in 6x plus 3 is that we look into the coefficients of the terms. We only have two terms in here. And 6 and 3 have a common factor of 3. And then we look into the variables. So here we have variable x. Here we don't have a variable, which means that no variable is common. So we're going to say that number 3 is the greatest common factor. So we'll take that out. And then we try to figure out the rest of the terms. Now remember that if you take 3 out of 6x, then we're left with 2x. And the way we know it is because now 3 times 2 would equal 6. But the way we normally do it in our heads is 6 divided by 3, 2. This is how we figure out what we have in here. Now here we have number 3, but 3 has the factors of 3 and 1, which means that if the factor 3 is out, then just number 1 is left inside, so 2x plus 1. Moving on to the next example. So 8x squared minus 7x. Same strategy. We look at the numerical coefficients. No common factor. We look at the variables. We have x to the power of 2 and x to the power 1. So what that means is that x is common. But what power do you think is common? Well, when it comes to taking out the greatest common variable, we always take out the variable with the lowest exponent. So we look into the lowest exponent, which means that with exponents 2 and 1, just x is common. And then the rest of the expression will be 8x minus 7. So if you expand back, then you will get exactly what we had in unfactored form. So 8x squared and negative 7x. Let's try another one. This time we have 25k6, 15k4. So 25 and 15 will have 5 in common. And k6 and k4 will have k in common. And the power we take out is the smaller power, so the power of 4, because that's what's common, right? So we're going to say that from 25 we're left with a 5. And then k6, we have k4 out, so k2 is in. And from 15, we take out 5, we're left with number 3. k4 is all out, so there is no k inside the brackets. Now, just for clarification, in case anyone is confused. So when you take out the common variables, the reason why we take out the smallest exponent is because that will be basically the common power. So k4 here would be k4 times 1, whereas k6 is k4 times k2. So k4 is common and not k6. And I think it's important to emphasize this because whenever we think of the word greatest common factor, people think that, oh, okay, so greatest, I have to look at the greatest exponent. But no, that's not how it works. So the greatest is a smaller power when it comes to the variable part. Now, next, we have 3 terms in here, so we're looking at more numbers, that's all. So it's the same strategy. So we're looking at 21, 28, and 7. They have a common factor of 7. Now, next we're looking at the variable c. So all the terms have a c variable. So we have powers 4, 2, and 1. So the common power would be c to the power 1. And now we have the coefficient d. So coefficient d is common or is present in every term, which means it's a common variable. And the lowest power that we see in here, since we have d3, 5, and d3 again, we're going to say is d to the power 3. And now we have to figure out what's left. So we're going to go 21 divided by 7, that's a 3. C4 divided by c, that's c to the power 3. And d3 and d3 is out, there is no d left in. So you can say d to the power 0, but that makes no sense to write. So 28, negative 28, 7 is out, negative 4 is in. Now c squared, that's what we had, c is out, so c to the power 1 is in. And d5, d3 is out, d squared is inside. Lastly, we have number 7 is O out, which means that the coefficient here is 1, but we don't really have to write a coefficient of 1 because in mathematics especially we want to keep things simple and easy to envision. Now we have the coefficient C, which is O out, and d to the power 3 is O out. And a common mistake I have to mention people make is, oh, there is nothing left, and they think that they have to close the brackets. Now remember that if you close the brackets in here, then you make this term disappears, because when you expand, you need to get 1, 2, 3 terms. So never do that. And we're going to have to write number 1. So think of it as a placeholder for this term, right? So that's the factor left. And with this, we're done. So next we're looking into binomial common factor. As you can see here in our examples here, we had all monomial common factors. And this time we're looking at binomial common factor, which is a very good skill to actually develop, especially when factoring bigger polynomials. So as you can see here, we have this product and this product. And in these products, the binomial is common. I'm going to highlight this one in here. As you can see, y plus 1 is common. So I will take this out and I will write the rest of the expression. So what's left in here is 3x and a 7z. So that's exactly what I'm going to write in the second binomial. And we're done. Next we have 2x, x minus 3 minus 5, x minus 3. So as you can see again, you can try this on your own, obviously. So x minus 3 is common. And the terms left from the entire expression are the 2x and the minus 5. And that would be the factored form. Now, sometimes you may see some more funny looking questions. And I'm just going to make up an example in here. So say that we have 2x times x minus y, and then plus 3, and then y minus x. So this could be a little bit of a harder question. Just came up with it because I think that's an interesting question that we normally like to discuss, especially to develop our thinking skills. So as you can see here, x minus y, y minus x look pretty much alike. But when you think about it, their signs are opposite. So here you have positive x, negative y, positive y. So when you see that the terms in an expression have exact opposite signs, right? Or in terms in two expressions have exact opposite signs respectively, that means that they are opposite expressions. So what that means is that instead of writing 3 times y minus x, we can write negative x plus y. I'm just rearranging the terms. And further to this, I'm not changing anything in the first part, that's why I'm not explaining it in detail. So we can take negative 1 out, and that will change this to x minus y. So if you take negative 1 out, so negative x becomes positive, positive y negative. And that will change the expression to become 2x minus 3. So I'm going to take it more slowly, actually. So 2x, x minus y. And then 3 and negative 1 will multiply to negative 3, and then x minus y. As you can see now, they are exact same binomials, so they're common. And we're going to take that out, and the rest of the expression will be 2x minus 3. Now, the first time you say this is kind of, a little bit of a novelty. But as you practice it, you can see right away when expressions are opposite, and you can jump actually from this step to this step more easily. But until now, practice and show the steps as needed. So it is very important to think with confidence, and the speed doesn't matter. The speed comes with practice. Now, Next, we're going to look at factoring by grouping. So factoring by grouping happens, or we usually use when we have more than 3 terms in an expression. So in this expression here, you have 4 terms. So what we're going to do is check and see if the terms have any common factors. So we're going to group the first 2 terms together and the second 2 terms together. It's not necessarily, it doesn't necessarily have to be the first and the last 2 together, but we try different ways, and that's the first grouping kind of strategy that I am thinking of for now. And if that doesn't work, then I can see why it doesn't, and I can search for other methods. So as you can see, the first 2 terms have a common factor of x. So I'm going to take out the common factor a, and I'm going to take a out, and then I'm left with x plus y here. And now here we have the common factor of 2 and then x plus y. So now you can see that we have a common factor of x plus y in both groups of multiplications or products. So x plus y can come out as a common factor, and then a plus 2 will be the other factor. So next, we're looking into this particular question. So let's take a look and see if we can group the first 2 together and the last 2 together. So let's hope it works. We have 9x squared plus 15x plus 3x plus 5. So the first 2 terms do have a common factor of 3x, so I will try to factor and see what I create here. So we have 9x squared, 15x, so in factored form here. And 3x plus 5, there is nothing we can factor there, and when that happens, what we're going to do is we're going to write a fake 1 in here, because 1 is the other factor. We need to make it visible so that we can factor more easily. So as you can see now, we have a common factor of 3x plus 5. We'll take that out. And the other factor would be 3x plus 1. And with this, we're done factoring by grouping. Now, factoring by grouping can be very simple. It can also be very complicated depending on the difficulty level of the polynomials that participate in the expression. And factoring by grouping is applied to more than 4 terms as well, but we're going to look at more examples later. Next, we're looking at factoring trinomials of the form x squared plus bx plus c. If you remember, we have called this a simple trinomial for the sole reason that the coefficient a is 1. So we have the steps all laid out for us, and I'm going to try to explain them as we practice. So if we have x squared plus 5x plus 6, remember that, first of all, we need to have the expression in the order from highest to lowest degree. And we search for 2 numbers that have the sum equal to 5 and the product equal to 6. So the way that I search for these factors in normal expressions, obviously this is quite simple and you can easily see what the 2 numbers are. But the strategy that we want to use is by starting with the product, because there is a limited number of integers that will multiply to 6, and there is an infinite number of integers that can add to a 5. So we're going to start with 1 times 6 and check and see if 1 plus 6 will give a 5, and that's not going to work, so we're going to say that that's not what we want. So, and then we're going to check the numbers 2 and 3. They multiply to 6, and 2 plus 3 will add to 5. So we're going to give this a go. And when we factor, it's very simple. We set up 2 sets of brackets, 2 pairs of brackets. They both start with an x because that's what produces the x squared. And then we write the 2 newfound numbers. So 2 plus 3. And with this, we're done factoring this expression. Okay. Now, another thing I want to keep in mind is that, sorry about this, whenever we look into these factors, we have to consult with the signs. If the product and the sum is positive, we know that the 2 numbers would be positive. Now, I made another question in here for you to try, and I'm going to do it as well. So I know that this is a simple trinomial. Both factors will start with an x. Simple because coefficient 1. Now we're going to look at two numbers, or we're going to try to find two numbers with product of 28, and we want their sum to be negative 29. Now I want you to think about it. If the two numbers will add to negative 29, they're either both negative or one of them, the bigger one, has to be negative. But since the product is positive, it tells us that the two numbers must both be negative. So I'm going to start with my strategy, negative 1 first times negative 28. And surprisingly, actually, this does add up to negative 29. So this was not as hard. So we're done. This is the factored form. Now, we're moving on to the next question. Remember that we have to find the greatest common factor first before we start factoring polynomials, and especially when you see a minus in the first term, that always has to come out, even if it is just a negative sign, or which means the negative one. So check and see if negative 2 is a common factor. It seems that it is, and take that out. And continue factoring the rest of the expression. So our focus now will be on this simple trinomial, or as we call it, simple, right? And we have x and x in here. We have to figure out two numbers that will multiply to 12 and give a sum of 7. So 1 times 12, so they must be both positive, by the way, because the sum and the product is positive. That won't add to a 7, so we're going to try 2 and 6. So that is 2 plus 6 is 8, not a 7. So we're going to try the next factors, 3 and 4. The sum is 7. The product is obviously 12, so 3 and 4. Now something to mention, worth mentioning, is that the order in which you place these numbers doesn't really matter, because these are multiplications of expressions, and in multiplication the order won't matter. Now, let's try another question. I encourage you to try this on your own first, and then watch the explanation after. So again, as you can see here, we have a negative coefficient. We want to take this out. And negative 1 over 2 is a greatest common factor. I take this out with confidence because I see that the other numbers are even, so it's going to end up being a good story in a way. So we're left in here with x squared, and now we have to figure out what this becomes. Now remember that whenever we take out a common factor, let's say we take out negative 2, when you figure out what's left of negative 14, you go negative 14 divided by negative 2, 7. Or negative 24 divided by negative 2, 12. Now we do the exact same thing when we have coefficients that are in fraction form. So we're going to go ahead and divide, and I'm just showing this for now as our first example in this lesson. But what we're going to do is divide 6 by negative half. Now remember that division is like a form of multiplication. You just have to flip the fraction. So that will make negative 12. So that means that the positive 6x has turned to negative 12x. Whenever we taken out common factors, like we are under the impression that all these numbers will become smaller, but that's not true when we take out numbers that are less than 1, obviously. So in the same way, we have negative 16. So negative 16 divided by negative 1/2 would be negative 16 times negative 2 over 1, which will make a positive 32. So negative 1 over 2, that's one factor we cannot deny. So it's going to sit there and wait for the rest of the expression. And we need to find out two numbers that have a product of 32 and the sum of negative 12. If the product is positive, it tells us that the numbers have the same sign, either both positive or both negative. But because the sum is negative, it tells us that they have to be both negative. So I'm going to start off with negative 1 times negative 32. That does not add to negative 12. So I'm going to try negative 12 times negative 16. So product is 32, but sum is negative 18. I'm going to try the next number. Well, by the way, the negative 3 won't fit into a 32. So I'm going to try negative 4. So for negative 4, we need the negative 8. And it seems that the sum of negative 4 and negative 8 is indeed negative 12, so this would be our lucky numbers. So that would be the factored form. So in the next part of this lesson, we're looking at trinomials of the form ax squared plus bx plus c. This is the more complicated trinomial. So in this case, we're looking into two numbers, so breaking down the middle term into two numbers that will have the sum equal to the middle term itself, right, b. But the product this time, unlike in the previous example when we had the product c, now we're going to have the product c times a. Now, when you think about it, why didn't we, take into account this number in the previous expression? Remember that that number was 1, and c times 1 was just c. And that's why we didn't have to worry about the coefficient here. We only looked at the product that had to be equal to the constant c. So let's take a look at our first example and see how we go around this. So we're going to break down the middle term into two numbers that will still have the sum of 8. But the product will have to be 4 times 3, which is equal to 12. So the two numbers that multiply to 8 and multiply to 12 and add to 8, I'm going to start with 1 and 12. They must be both positive. So 1 plus 12 is 13, so that won't work. Next I have 2 and 6. 2 plus 6 is 8. So we're going to say that 2 and 6 are the numbers we need. So plus 2x plus 6x plus 4. Now again, if you're wondering which one to put in first, 6x or 2x, again, it doesn't matter. So next, we will factor by grouping. And good thing is that we just actually reviewed factoring by grouping, which is kind of nice. So we'll group the first two terms together. We don't have to wonder about how to group them. So we always group the first two together, the last two together, and it has to work. Okay, if it doesn't work, it means that we've made an error in either finding these numbers here or an error in how we work for the rest of the solution. So you see that the common factor of x is for the first group of terms, and a common factor of 2 is for the second group of terms. And now you can obviously see that 3x plus 2 is a common binomial, and that will come out as the greatest common factor, and the rest of the expression would be x plus 2, and this is a factored form. So next, we're going to continue with the trinomial 3x squared plus 5x plus 2. You can try this on your own first. So you have the sum of 5, and we need the product to be equal to, again, remember, 2 times 3 is 6. So we're going to say 1 times 6, that doesn't make a 5. 2 times 3, that adds to a 5. So 3x squared plus 2x plus 3x plus 2. And now we're taking out the common factor of the first two terms. Again, we don't have to think hard. We know what they have. They must have something in common. So we have a common factor of x here, and then 3x plus 2. And when you look at the next group of terms, they don't have any common factor. So we're just going to write 3x plus 2 here. So 3x plus 2 is a common binomial, and we're going to take that out. 3x plus 2, and then x plus 1, and we're done. Now, in the next expression, we are working with various polynomial expressions, and we're going to try to factor. Now, what is the strategy? So the strategy in this case starts with counting the number of terms. So when you see 4 terms, we have to consider factoring by grouping. But before we start factoring by grouping, we're going to check and see if we have any common factor we can take out, because we don't want to work with big numbers, big coefficients, because big coefficients means that we have to search for more pairs of numbers that will have the conditions for the certain product and certain sum. So I see that 3 is a common factor indeed, so I'm going to take 3 out. And then in brackets, we'll have x to the power of 3 plus 2x squared, and then minus 9x, and here we have 54 divided by 3, so an 18. And we're going to close the brackets. And we have 4 terms, which suggests we have to try factoring by grouping. I do see they have quite a lot in common. And these two have a lot in common. So I'm just going to leave them the way they are. I'll take out x squared. And then we have x plus 2 here. And for the next group of terms, we have -9, a common factor, and then x plus 2. Remember that -18 will become a positive here, right? And close the brackets. You see now we have this first in factored form, and this is in factored form as well. Now, we are going to take out the common binomial, which is x plus 2, and we have number 3 still there. We have the common binomial of x plus 2, and the other expression left is x squared minus 9. And wait a second. Now, I want you to think, are we done here? Have we completely factored? So it's pretty much in good shape. But if you look at the last factor here, we have x squared minus 9. This is difference of squares. If you remember the formula for difference of squares, we have a plus b and a minus b. And what we see in here is x squared minus 3 squared, so x minus 3 and x plus 3, and now we are happy. So this is completely factored. Now, here we have a little bit of a more difficult question. So we have 3x plus 1 squared minus 9x plus 1 minus 12. It's not difficult, really. Now, it's just an unusual format of the question. So what should get our attention is the fact that we have x plus 1 repeating here in 2 terms, and in one of them is to the power of 2 and the other is power 1. So that should remind you of something in the form 3a squared minus 9a minus 12. So now it looks more like the trinomials we've seen before. First things first, we're going to check and see if we have a common factor to take out. So we have 3, -9, -12. And it seems that number 3 is a common factor. And now we have x plus 1 squared minus 3 times x plus 1, and then minus 4. So next thing that we want to look at is this big expression in here. So for some people, it's easier to replace this with some variable a. So a squared minus 3a minus 4 and factor it. We can do that. So if we let this be some helping variable a, then this is going to look a little bit simpler, and you will see that it's a lot quicker to factor it. So that would be, let's say, a here minus 4 and a plus 1. So 2 numbers that multiply to -4 add to -3. So product negative, the 2 numbers will be opposite signs. Since the sum is negative, the bigger number is a negative. But remember, we cannot leave the answer in this shape because no one will understand this answer if they gave you this question, right, with x. So we're going to be like, who is a? So we're going to bring x plus 1 in, and then x plus 1. Now remember that the x plus 1 is in the place of the variable a again, so it's coming back. So x plus 1 is making a comeback, and we have the factored form as x minus 3 here, and then x plus 2, and that would be the final answer. Now, I have a lot of people always asking me whenever we go over this concept, okay, so can I just expand and simplify this and then factor? Well, technically, there is nothing wrong with that, but the idea is that expanding this, simplifying, is going to make the road a little bit longer and the opportunities for mistakes more frequent. Plus, we want to actually practice new ways of thinking, so expand our imagination a little bit. So we're moving on to our next topic, which is the perfect square trinomials. Remember that anything that comes from squaring something creates a perfect square. Let's say, for example, 1 squared is 1, so 1 is perfect square. 2 squared is 4, 4 is a perfect square, right? X to the power 3 squared is x6, so the x6 is a perfect square, and so on. Now, when you square a binomial, a plus b squared, we've seen this before, we get a plus b times a plus b, and if you FOIL here, you get a squared. I know that most of you know this, but I still have students always say, oh, that's the reason why, even in grades 11 and 12. So here we go. So a squared plus ab, and then plus ba, and then plus b squared. So when you simplify this, you get a simplified trinomial in the form a squared plus 2ab plus b squared. Now remember where this trinomial came from. It came from squaring a binomial, and that's the reason why we call this a perfect square trinomial. So if you have a minus in between, you're going to get the exact same thing, but this time it's going to be a squared minus 2ab and then plus b squared. So again, this would be a perfect square trinomial. Now, why do we want to study them? Because many trinomials can be perfect squares, and especially when coefficients are very large, and it's easy for us to kind of see that they are perfect square, they fit into this formula. It makes it easier for us to bring them to factored form. Now, the last special expression or special polynomial is the one that comes from multiplication of a plus b with a minus b. We just mentioned in the previous example. So here we have a squared and then minus ab, and then plus ba, and then minus b squared here. So that would be equal to a squared minus b squared. So we call this the difference of squares. So remember, perfect square trinomials, difference of squares. And the name is in the meaning of it, the difference of two square terms. So we're going to look at various examples and try to factor together. And whenever you see two terms, you always have to think of difference of squares. So don't forget, greatest common factor will always come first. So the greatest common here is 8. I'll take that out, and x squared minus 9y squared. So what we have in here is a term to the power of 2 minus another term to the power of 2. So 9y squared is 3y to the power 2. So we have 8 and then x minus 3y and then x plus 3y. Next we have 16 minus y minus 3 squared. So this is a little bit different. What gets my attention is the minus in between these two terms and this squared in here. So I'm going to try to write 16 as something squared if possible. So we have 4 squared minus y minus 3 squared. And the factored form now will have to be 4 plus y minus 3, and then 4 minus y minus 3. Now, one thing that I want you to get your attention for is when you are minusing here y minus 3, you're minusing a binomial. It is very, 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 very important that this is kept in brackets. And what we get now in a more simplified form is y plus 1 for the first factor. And the other factor would be 4 minus y plus 3. So one more step, y plus 1, and then we have negative y plus 7. So this is a distant form of distant factor form, but it is normally not acceptable to have a first coefficient and negative, so we're going to take that out. And we have negative 1 y plus 1 and then y minus 7, and that would be our final answer. So let's move on to our next question. Let me just make this right here. Now, the next example, we have two binomials to the power of 2. And again, this would be the formula a squared minus b squared. So we have, I'm going to open up square brackets here so to keep the expression safe. So 2x plus y plus 2x minus y. And then we have the other factor, which will have a minus in between. So 2x plus y minus 2x minus y. And now we'll simplify 2x plus y plus 2x minus y, and then 2x plus y minus 2x plus y here. Simplify some more. We have 4x. The two y's will simplify. And the other term will end up being just simply 2y. Oh, this is beautiful. So the final answer would be 8xy. So these three monomials, all that work. All right, so moving on to our next question. And we have 9a squared minus 24a plus 16. So I'm looking for greatest common factor, and I don't see any. So they have 3 in here. These two have a 4, but not all of them have the same thing. So I am going to check and see how I can factor it. I do see that the last term is a perfect square term. And the first term is also a perfect square term. Now, if the middle term happened to be double the first with the second, then that would be a perfect square trinomial. So that's how I check. So you check the first and the last term if they're perfect squares, and then you express them as powers of 2. Check and see the middle term if it fits into the formula. So as you can see here, 2 times 3 is 6 times 4, 24a. So that would be part of the formula. So it is a perfect square trinomial indeed. So the factor form is going to be 3a, and then we have a 4, and we always use the sign of the middle term. And this is to the power of 2. And this is done. So instead of breaking down the middle term, working with these big coefficients, we just recognize that this is perfect square, and we did it a lot faster. So moving on to our next question. So you can try this always on your own. And we have 5 to the power of 2. That got my attention. It's a perfect square. 4x squared is 2x squared. The middle term is double times 2x times 5. Let's see if that is true. So if that is equal to 20x, it is indeed. So that means that the factored form is going to be 2x. And then we have the 5, and the sign is going to be the middle term sign, 2x plus 5 squared. Let's try one more. This time we have more than a variable. Nothing to worry. We know the trick in here from grade 10. We have 2p to the power of 2, 5q to the power of 2. Let's check the middle. The middle, we want it to be double of the first term 2p with the last term 5q. So that would be 20q in here. So that's what we have. So that's a win. And we're going to factor it as a perfect square trinomial, 2p here, 5q there. And in the middle, we place the plus sign because that's a sign of the middle term as well. So let's look at this interesting question. So you see a power of 6 and you think, I never learned how to factor powers of 6, and I don't see how I can take out any x's in here to make this into power 2. So we're going to look at this expression a little bit differently. So we're going to look at x to the power 6 as a power of 2. And what we have to put inside in here is the x to the power 3. And as you can see here, you have x to the power 3 as well. So this is practically a second degree polynomial. And what we're going to do here is treat x to the power 3 as some variable a. If you want to, you can replace it by a, definitely. A squared minus 18, and then times a plus 81. Okay, and then from here on, you can start factoring. So this is a perfect square. 81 is a perfect square. That's a 9 squared. So let's check the middle. We want it to be double of a with 9, which it is, which means that the factor form would be a minus 9 to the power of 2. So even better, then we're going to say that instead of a, we can bring x to the power 3, obviously. So that's x power 3, and then minus 9 to the power of 2. And this will be the factored form of it. So you can write it as x3 minus 9 squared, or you can write this as x3 minus 9 times x3 to power 3 minus 9. Try to expand and simplify. You'll see it works. Now, we're going to look at our last example. I see 121 here. It's a perfect square number, 11 squared. Now, x to the power 4. I kind of got used to this idea, and I shouldn't be worried about seeing powers greater than 2. So that's x squared to the power of 2. And I have an x squared right here, actually. So the pattern is solid here. And we're going to say that we want the middle term to be double of the first term x squared and the last one, which is 11. So that's a 22. So we have a perfect square trinomial. So that will be x to the power of 2. And this is going to be 11. And the sign in the middle is going to be a plus. And this is going to be the factored form of it. And this was lesson number 2 in the grade 11 advanced, in grade 11 functions. And I hope you found the instructions useful. And thank you for learning with me again. Bye for now.